Dear students, today we will talk about Fermat's principle. And then, using the same principle, we will try to understand the laws of reflection and laws of refraction of light in a better way. Now, firstly, let us note down what is Fermat's principle. It states that when light passes through a medium, or a set of medium, it follows a path which takes shortest time. This is also very obvious. So, whenever light passes from one point to another in any medium, it will follow a path that takes the shortest time. This also means the path in itself will be the shortest path. Light will not take this path, it will not take a zigzag path, it will take a shortest time or shortest length path. This is very logical to understand, and this principle is called as Fermat's principle. Now, you should also remember that Fermat's principle is very obvious. I mean, it's very logical if you consider homogeneous medium. By homogeneous medium, we mean a medium which is made up of same substance. For example, if light is traveling through air, it is traveling through air only. If it is traveling through glass, it is traveling through glass only. If it is traveling through water, it is traveling through water only. But it can also happen that light may have to pass through a set of medium. Then we know that bending of light will take place. We understand that bending of light will take place. And I have already told you about optical path and geometric path. I hope you remember, you recall that. Optical path and geometric path. Therefore, what will happen in that case? That the total optical path will be the sum of optical paths through different media. Suppose if light happens to pass consecutively through three mediums, then total optical path S will be mu1 x1 plus mu2 x2 plus mu3 x3 and so on. So in a proper way, you can write it that S is equal to integral from some point A to B mu times ds dash. Okay. So if I try to write it in this manner, for example, light had initially it had come from air, then it goes through glass, it bends, then it goes through say water, it bends further, then it comes out in air, it bends again. So the total path length will be obviously the sum of this and this and this, but not the geometric path x1 x2 x3, but the optical path. Because I told you earlier that the optical path is always same. In a given time, light travels the same optical path in all the media, right? So this is how we can state the Fermat's principle. And if you have understood that, we can use the same law to describe reflection and refraction in a better way. So let us first go to the laws of reflection. The first thing is law of reflection. Now, how many laws of reflection are there? All of you understand that? You have read that in school level, that the incident ray, the reflected ray, and the normal to the surface at the point of incidence fall in the same plane. Again, I am repeating, you know it's in school level that the incident ray, the reflected ray, and the normal to the surface at the point of incidence fall in the same plane. Suppose I have a mirror MM dash by the name MM dash. This is the mirror, okay? And in this mirror, this AO, for example, is the incident ray, at the point O. At this point, I draw a normal to the surface. This is N, and this ray gets reflected along OB. Now, I can assess that AO, OB, and normal, they all fall in the same plane, a plane which is perpendicular to the plane of this mirror MM dash. Suppose the name of the plane is A, B, C, and D. So it is very obvious, very logical that all these three, incident ray, reflected ray, and normal, they fall in the same plane. But let us suppose otherwise, that they don't fall in the same plane. This means that this A and B meet at some other point O dash, which is outside this plane. Then let me join this BO dash. Let me join this AO dash. But using Fermat's principle, which says that light will follow the shortest path. Obviously, this AO dash and O dash B will be greater than AO plus OB. But because we know that light follows the shortest path and shortest length, and it follows the shortest time, this AO dash plus O dash B will not be a preferential path. What will be a preferential path instead? AO plus OB. So this is how, using Fermat's principle, we can prove the first law. Now let us go to second law. Second law of reflection. What is that? Angle of incidence is always equal to angle of reflection. Angle of incidence is the angle which the incident ray makes with the normal, and angle of reflection is the angle which the reflected ray makes with the normal. Now, I suppose that the incident ray and the reflected ray, I measure them from certain heights, A and B. I don't assume initially that they are equal. Then I consider the distance of this point from O equal to x, and the distance of these 2 points is, suppose, between these 2 points is d. So obviously this distance will be d minus x. Okay, so what is the total path followed by the light? Total path length is how much? AO plus OB. AO plus OB. And what is the time taken to cover this path? Because we know that time is how much? Distance by velocity. So it is AO plus OB. And what is velocity? Velocity is the velocity of light, c. Now find this AO. From this triangle you can find that this AO is equal to a square plus x square, simply under root. So this is a square plus x square under root times. And for this OB, what can you write for OB? This is b square plus d minus x square. So this is b square plus d minus x square. This is also under root. Simply from the right angled triangle this and right angled triangle this, you can find how much is AO and OB divided by C. Right? So let me rewrite it, that this time is equal to, again I am writing, this is a square plus x square, this much, b square plus d minus x square, this much, under root times, divided by C. Now, using the Fermat's principle, we again emphasize on the idea that the light will follow the shortest path, the shortest length, the shortest time. Okay, so if it has to be small, then the derivative dt by dx should be 0. There is one point amidst this that I want to mention. For example, there is some process which follows a trend like this. We are plotting something against something. Yes, so we know that this is the minimum value on x, okay, and this is the maximum value on x-axis, minimum value and extreme maximum value. Because they are the two endpoints of the graph, we call them extremum points. Extremum. Two endpoints or two extreme points, one minimum and another maximum, they are called as extremum. And the peak value, the best value, this is called the optimum. Because generally students make a mistake that maxima is perhaps this value. No, this is not. Maximum is the endpoint value on the x-axis. Minimum is the beginning value on the x-axis. Because they are on the two extremes of the graph, we also call them extremum. Both of them are called extremum. And the peak value is called optimum. Right? Now, for anything to be minimum or maximum, its derivative has to be 0. Okay? dt by dx has to be 0. Now, from here we move to the next part. So let us derive it. Let us differentiate this expression with respect to x. So do it. You can easily do it. What is it? It is dt by dx will be how much? Because we are doing a differentiation with respect to x. So this c will be common at the first place for both the two terms. This a square plus x square term will come in the denominator. I hope you understand that. This is because this will be 1 by 2 minus 1. So that will be minus 1 by 2. So it will come in the denominator. Okay. So then there will be the interior differentiation of this x square. That will be 2x. Okay. Internal differentiation. Similarly, this will be how much? B square plus d minus x square whole raised power 1 by 2. And then this d minus x, 2 times d minus x. Okay. And this entire thing will be equal to how much? 0. Told you initially that dt by dx has to be 0. If it is an extremum value, it has to be 0. So this 2 gets cancelled throughout. Okay. So you can write it as x by a square plus x square whole raised power 1 by 2. This is equal to, because this 2 gets cancelled, this will be x minus d now, because I took this on the right side. So because of minus sign, it will be x minus d now. So it will be b square plus d minus x whole square. And if you find these ratios from the graph, you will find that one of it is sine of angle of incidence and another is sine of angle of refraction, because sine is base by hypotenuse. Base by hypotenuse. Here the base is how much? A, and here the base is how much? B. And the hypotenuse here is AO, here it is OB. You can yourself find that these two, okay. So this is how we can do it. So this is sine of I is equal to sine of R, or in other words, I is equal to R. Angle of incidence is equal to angle of reflection. I hope you have followed that. Okay. So in the next video, we can use the Fermat's principle to verify the laws of refraction of light. Okay.